So we're gonna look at this article about AI slowing down open source developers. So last time we read an article about AI replacing developers, and something that I had a inkling about was that AI is actually slowing some people down. So AI found an article to that effect, or more accurately, Nebu found an article to that effect, since we're citing sources properly. So let's give it a little read through. AI slows down open source developers. Peter Noir can teach us why. Meter recently published a paper, and I did look at this paper a little bit. I am not super impressed that they are published on archive. Their read the full thing link goes to the unpeer reviewed publishing slop journal thing. So is this all slop research? Who knows? But it exists. So they recently published a paper about the impact AI tools have on open source developer productivity. They show that when open source developers working in code bases that they are deeply familiar with use AI tools to complete a task, then they take longer to complete the task compared to other tasks where they are barred from using AI tools. Interestingly, the developers predict that AI will make them faster and continue to believe that it did make them faster, even after completing the task slower than they otherwise would. So there's a couple of interesting observations here. First off, there's some confirmation bias going on in the participants, it sounds like. And second off, this sounds like a really small, cherry pick subset of people. So we'll see how that plays into results. When developers are allowed to use AI tools that take 90% longer to complete issues, significant slowdown that goes against developer beliefs and expert forecasts. This gap between perception and reality is striking. Developers expected AI to speed them up by 24%, and even after experiencing the slowdown, they still believed AI had sped them up by 20%. Oh, hey, look, they even say we can't generalize these results to all software developers because they're super heavily cherry picked. Developers in the study are a very particular sort of developer working on very particular projects. I wonder if this article will talk about her. Do I have to? How long is the big paper? Yeah, we're not reading that. The developers in the study are a very particular sort of developer working on very particular projects. They're experienced open source developers working on their own projects. Okay. So this is like project leads that they're studying. I wonder if they have, can we at a glance, do they have a experiment design? Do they have a section on their participants? Oh, developers and repositories. We recruited experienced developers from large open source repositories to work on real tasks defined on these repositories. Developers came from a mix of our professional networks and from outreach to active contributors to large popular GitHub repositories. The developers are experienced software engineers, typically over a decade of experience, and are regular contributors to the repositories we use. On average, they have 5 years of experience working on the repository, representing 59% of that repository's lifetime, over which they have made 1,500 comments to the repo. As an incentive to participate, we pay developers $150 an hour. Appendix G provides more details about our recruitment and incentivization process. Repositories themselves are large and mature. On average, they have 23,000 stars, over 1 million lines of code, 5,000 forks, 20,000 comments, and 710 committers, and they broadly have a very high quality bars for code contributions. For example, one set of repository contribution guidelines concludes, few. While the above may be a lot to remember, the motivation of enforcing process is to ensure that all code contributions meet a certain quality threshold. Section G.7 further details statistics about individual developers and repositories. Okay, so everyone they're doing here is an expert, and they're all contributing to big projects with lots of code, and they're very mature. So they got good people doing this, it sounds like. The study tells us that the current suite of AI tools appears to slow such developers down, but doesn't mean that we can assume the same applies to other developers. For example, we might expect that for corporate drones working on Next.js apps that we were mostly built by other people who've long since left the company, see huge productivity improvement. So they're postulating, the postulation here is that the source article is considering experts, so the results for what's the nice way of phrasing this?
Filtered.
Might be different. One thing we can also do is theorize about why these particular open source developers were slowed down by tools that promise to speed them up. So this is some speculation. Ugh. Ooh, did the original article do any speculation? Wait. Yeah, the poor web devs. This is only a 12-page paper. What kind of appendices do they have here? Extended discussion, author contributions, factor analysis, empirical strategy. They have all of their work in here. I wonder if that means that they're doing anything weird. If I was good at statistics, I might be able to analyze that, but This is more detail than, like, I've seen, like, 50-page journal articles, right? Let alone for, like, in a little 10-page conference type paper. On archive, no doubt. I wonder why they haven't sent this somewhere good, or if this is it labeled as a preprint? Is there anything preprint indicator? Hmm. I wonder why they didn't send it somewhere good. Because at a glance, without looking at any details, it looks like a very well put together paper. One thing we can also do is theorize about why these particular open source developers were slowed down by tools that promise to speed them up. I'm going to focus in particular on why they were slowed down, not the gap between perceived and real performance. Inability of the developers to tell if a tool sped them up or slowed them down is fascinating in itself, probably applies to many other forms of human endeavor, and explains things as varied as why so many people think that AI has made them 10 times more productive, why I continue to use Vim, why people drive in London, etc. I just don't have any particular thoughts about why this gap arises beyond I do have an opinion about why they're slowed down. So, why are they slowed down? A while ago, I wrote somewhat tangentially about an old paper by Peter Nahr called Programming as Theory Building. That paper states, programming properly should be regarded as an activity by which the programmers form or achieve a certain kind of insight, a theory of the matters at hand. That is to say that the real product, when we write software, is our mental model of the program we've created. This model is what allows us to build the software, and in future is what allows us to understand the system, diagnose problems with it, and work on it effectively. Okay, so that's his postulation. If the hypothesis is that programming is building a mental model, then if the AI does it, the AI has the mental model, and you have a bunch of code to read and barely understand, maybe. But if we're talking about experienced devs who are like doing a patch on, I don't know if do they what did they say? Section G? I'm guessing it's all anonymous, but do they have any details about repos? They probably don't. Yeah, they don't. Participants, yeah, participants are all, oh, hey, look, tables of repositories. Amino, Studlib, GHC, so Haskell developers, is that correct? Haskell developers, Cabal, uh, Flare, JS DOM, Hypothesis. What is Hypothesis? Property-based testing library for framework. Framework for Python. Thrive, Scikit-learn, BT-Nox, clean face transformers. Some people who requested to be anonymous. Okay, so these are good programmers. It looks like the Haskell people, GHG, are doing some really cool stuff. So, but to go back to the mental model thing, right? If you're a dev who's contributing a patch to the Haskell compiler, um, how much mental model stuff is happening here? It's like you should already have a pretty good mental model of the program, right? Like your one little feature isn't going to change the overall mental model of the program too much. So we're going to assume that I'm not questioning the premise of this and say that if you agree with this theory, which I do, then it explains things like why everyone hates legacy code. Okay, fair. Why small teams can outperform larger ones, because I guess they have better models. Why outsourcing generally goes badly, etc. Okay, when you start bringing okay, but so that all makes sense. But okay, we'll let him cook. We'll let him cook. What do you say, Russell? Shall we let this poor man cook? We know the programmers in Meter's study are all people with extremely well-developed mental models of the projects they work on. We know the LLMs they used had no real access to those oh, okay, so this is the angle. The expert devs have a better mental model than the LLM does. Okay. The developers could provide chunks of that mental model to their AI tools, but doing so is a slow and lossy process that will never truly capture the theory of the program that exists in their minds. By offloading their software development work to an LLM, they hamper their unique ability to work on their code bases effectively. Think of a time that you've tried to delegate a simple task to someone else, say putting a baby to bed. You can write down what you think are unambiguous instructions, like give the baby milk, put it to bed. If it cries, do not respond. But you will find that 9 times out of 10, when you get home, the person following those instructions will do the exact opposite of what you intended. Maybe they have gotten the crying baby out of bed and taking it on a walk to see some frogs. Yeah, yeah. For some reason, it always takes like an hour of back and forth for someone to understand what you mean about any one thing. It's very, very frustrating. The mental models with which we understand the world are incredibly rich, to the extent that even the simplest of them take an incredible amount of effort to transfer to another person. What's more, that transfer can never be totally successful, and it's very hard to determine how successful the transfer has been until we run into problems caused by a lack of shared understanding. These problems are what allow us to notice a mismatch and to mutually adapt our mental models to perform better in the future. When you are limited to transferring a mental model through text to an entity that will never challenge or ask clarifying questions, which can't really learn, and which cannot treat one statement as more important than another, well, that task becomes essentially impossible. Okay, okay. I'm on board with this premise so far. This is why AI coding tools as they exist today will generally slow someone down if they know what they're doing and are working on a project that they understand. Okay, but this is all, to be fair, this is all speculation. Like, it's all reasonable sounding, but I don't see anything here tying back to the paper that talks about any evidence for this. So should I ban large language models at my workplace? Well, maybe not. In the previous paragraph, I wrote that AI tools will slow someone down who knows what they are doing and who is working on a project they understand. And for the poor web devs, that may or may not be true. Does this describe the average software developer in industry? I doubt it. Does it describe software developers in your workplace? He's not gonna he's not gonna say it, but I will, and I'll say it, I doubt it. It's common for engineers to end up working on projects which they don't have an accurate mental model of. Projects built by people have long since left the company for pastures new. It's equally common for developers to work in environments where little value is placed on understanding systems, but lots of value is placed on quickly delivering changes that mostly work. In this context, I think that AI tools have more of an advantage. They can ingest the unfamiliar code base faster than a human can and can often generate changes that will essentially work. I wonder how much technical debt. So, technical debt is like a very abstract concept that we have. Like, every bad decision you'll eventually have to pay for. Every bad decision now will like build increasing amounts of work later on. I wonder how many bad decisions the AIs generating code bases are going to make that we're going to have to pay for in like 10 years. I wonder what kind of nightmare that's going to be. So, if we take this narrow and short term view of productivity and say that it is simply time to produce business value, then yes, I think that an LLM can make developers more productive. I can't prove it, not having any data, but I'd love if someone did do this study. Hey, Russell, you should go do this study. It would be a great bachelor's thesis. If there are no takers, then I might try experimenting on myself. But there's a problem with using AI tools in this context. What about building mental models? Okay, so if you don't have a mental model of a program, then maybe an LM can improve your productivity. However, we agreed earlier that the main purpose of writing software is to build a mental model. Ugh. That the main purpose of writing software is to build a mental model. Okay, that's an assertion and a bit of a leap. We agreed earlier that that it's an important, like, essential piece. I'm gonna be the data for the study. Good luck, Russell. We agreed that it's gonna be an essential piece of writing the software, but we agreed earlier that the main purpose is to make the mental model. The main purpose is to deliver whatever logic you want to create. It's to make the game engine or the game or the web browser or the Haskell compiler or whatever. If we outsource our work to the large language model, are we still able to effectively build the mental model? I doubt it. I also doubt it. Ooh, there's a citation here. What is this? One of the commonly suggested uses of Cloud Code et al. Is that you can use them to quickly onboard into new projects by asking questions about that project. Does that help us build a mental model? Maybe yes. Is generating 10 times faster than a normal developer lead to a strong mental model of the system that is created? Well, certainly not. Okay, that's fair. So should you avoid using these tools? Maybe. If you expect to work on a project long term, want to truly understand it, and wish to be empowered to make changes effectively, then I think you should just write some of the code yourself. If, on the other hand, you are just slopping out slop at the slop factor, then install Cursor and crack on. You only live once. I don't necessarily agree with this. There are often a lot of really small things that like wouldn't contribute to the mental model of the program. So like well, I guess this is like an artifact of the fact that I'm a C/C++ developer and the standard libraries kind of suck, so we have to write our own a lot. I find myself writing like string reverse or do this little common math thing like matrix inverse or matrix inverse usually in like shader languages or stuff, right? And after the 10th time you've written that stuff, you don't want to write it again. There's like no mental model point in writing it again. It's just like repetitive math tedium. So why not have the AI generate like those boring features that nobody wants to write that we have to write over and over again since we're C++ developers? That's a little bit less the case for like the poor web dev. Like JavaScript has a lot of those things, and if JavaScript doesn't provide the thing, like, just about anything you would need in that category is an npm install away from being available. So, eh? What are these extra notes? This is to say that there couldn't be AI tools which meaningfully speed up developers with a mental model of their projects, which help them build those mental models. But the current suite of tools that exist don't seem to be heading in that direction. It's possible that if models improve, they might get to a point that there's no need for a human to even hold a mental model of software artifact. If we get to that point, right, I suspect that there's not going to be much of a need for a human to be involved, honestly. But we're certainly not there yet. And I don't know if we'll ever get there. I should throw. You know what, we're gonna look up that video. AI is approaching its limits. What are the limits? There's some video to this effect that I saw. It's saying that AI is approaching some computational line, some computational asymptote. So it may not be getting incredibly better than what we have now. Don't install cursor, it sucks. Use Claude code like an adult. Don't install actually let's look that up. Claude code. Deep coding at terminal velocity. Your code's new collaborator. Is this command line AI from concept to comment? Watch as Cloud Code tackles unfamiliar deep coding at terminal velocity. Cloud Code embeds Cloud4 Opus, the same model that researchers and engineers use right in your terminal, has deep code-based awareness and the ability to edit files and run commands directly in your environment. How much? Do you need how much money do I have to shell out to have Claude? Here we go. Per month, the annual subscription discount, $200 billed up front, $200, $20 at billed monthly. $20 at billed monthly, $17. Huh. Well, we're gonna have to look into that. That's the terminal part makes me a little intrigued with what exactly they're offering there. Void editor. Use Void like an adult. Don't give who makes Claude? Who makes Claude? AI? It's like Bloomberg or something, right? Well, the Anthropic. Don't give Anthropic your money. Get Olama downloaded and get Void installed and do it yourself.